Okay. So we are going to start here. So we have aliphatic. Firstly, first classification is, so generally we are having uh, aliphatic. Second type is aromatic. Third is polar. Fourth is basic. Fifth is acidic. Sixth is sulfur containing. And seventh is our 20th amino acid, which is proline. So this is basically the classification. Okay. So first, this is something which you need to learn or understand it properly. The first that we have here is here we know that we are talking about something regarding C. So here we are talking about C having R group, H group, NH2, and COH. Based on this R group, we are saying that how differently it is there. If you're talking about the aliphatic, that means all the R substitution has to be aliphatic. So first type we have is if R is equals to H, then the name is glycine, and the three-letter code that we give for the amino acid is GLY, and one-letter code is G. If R is your CH3, then it is alanine, three-letter code is ALA, and the A is the one-letter code, followed by if we have CH, this isopropyl group with CH3, then it is called as valine, Pal, and V. Now next, if we have CH2, CH, CH32, then it is called as leucine. Three-letter code is LEU, and one-letter code is L, followed by if we have CH, CH2, CH3, and here CH3, then it is isoleucine, which is ILE and I. So this is the classification for the aliphatic amino acid. So you need to know that these aliphatic amino acids are hydrophobic in nature. So first classification is done. We will move to next classification, which is our aromatic amino acids. We have here aromatic. Of course, the R group has to be aromatic. So in case of R, we have CH2 group, which is connected with phenyl group. So this is called phenylalanine, and the name is PHE, and one letter code is F. Please remember these one letter codes because directly question can come from this one also. F, followed by we have CH2 group, but with a fused ring, that is indole ring. This is your indole group, and this is called tryptophan, which has a three-letter code as TRP and one-letter code as W. Now, the last one, that aromatic category we have is CH2 and phenol group. So this is your phenol group. This is called tyrosine. And the three-letter code is TYR and one letter is Y. So none of the things are having their starting letter code. Be very careful. F for phenyl, W for TRP, and Y for TYR. So please be very careful. This is the second classification, which is aromatic. Now we are moving to third one. So we are here. If we have simple CH2OH group, then it is called serine. The three-letter code is SER and the one letter is S. If we have COH and CH3, then it is your threonine. The code is THR and T. Followed by if we have CH2, C double bond O, NH2 group, then it is asparagine, which is ASN, and code is N. If we have one more CH2 in this group, C double bond O, NH2, then it is glutamine. So this is GLN and code is Q. So these groups, they create or induce polarity in the system as they have polar groups, right? So if you have polar groups like OH, NH2, they induce the polarity in the system. So this is our third type. Now moving to our acidic point group, acidic amino acids. So there are two types of acidic amino acids. One is having CH2, C double bond OH. This is called aspartic acid, and the three-letter code is ASP, and it is D. Similarly, we have CH2, CH2, COH. This is your glutamic acid. GLU, and E. You need to remember that this is having pK of 3.2, 4.5 to have it in a carboxylic acid form. Otherwise, it would convert to, at higher pK values, it would convert to your carboxylate because it would release that H positive. Okay. Now moving to our basic amino acids. So these are three in type. So first we are starting with, there are one CH2, second CH2, 3, 4, and then NH2 group. So this is called lysine. Letter code is LYS and one letter code is K. Then we have CH2, 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 and in middle we have NH, then C double bond NH, and then NH2. So this group is guanidine. This is arginine and symbol is ARG with R. Then last one that we have is CH2 and imidazole ring NH N. So this is your imidazole ring, and this moiety is called as histidine amino acid with HIS and H. Followed by sixth classification that we have. The first one is simple CH2SH. This is called cysteine, letter code CYS and C. Then we have CH2, CH2, S, CH3. This is methionine, MET, M. Then last one is CH2, SEH. So this is sulfur or selenium containing, you can say, because sulfur and selenium have both the same properties. So it is selenocysteine. If you can see clearly that in place of SH, here it is selenium. It is named as SEC and symbol is small. And the last amino acid that we have kept it separately, that is 20th amino acid, which is having this kind of structure. So this is basically a secondary amine. This is not a tertiary amine. So it is not a primary amine. It is a secondary amine. Rest other amino acids that we have talked about, they are NH2 groups. This is rest 19 amino acids are primary amines. Secondary. Okay, and its name is proline. We have some usage of the amino acid. So amino acid used, they form proteins, as I have mentioned, by peptide linkages, CONH. How they form it. So if I am having NH2, C double bond Cr1, H, C double bond O, OH, plus another group NH2, Cr2, this would be different, and COH. Both are primary amines, and this H and this H2, when they undergo condensation, loss of H2O, that would give you NH2, Cr1H, C double bond O, so you can just write here. So this would have OH and H loss. So this would go, and therefore we would be having CO, NH, Cr2, H, C double bond O. This would make a amide to the peptide. And based on that only, we will be having different combinations of amino acids, and therefore it would form a protein molecule. So this is all about the basics that we had to learn about. So what we started with, so we started with symmetry elements and their combinations, which we have already seen, talking about identity, inversion center, CN, SN, so on and so forth, and their combinations, non-rotational groups, single axis, dihedral, and cubic groups, followed by we have tried to find out all the symmetry elements in octahedral symmetry, which is very important, taking the consideration of its vertices, faces, and edges, and finding out firstly the C4 axis, highest proper axis of rotation, and how it is passing. Then we have seen how many operations can be possible from C4, and then C3, followed by C2, and the corresponding planes and other things, and inversion center as well. So when we have done this one, then we have seen the chirality and symmetry combination, that how it gives mirror images and which chiral point groups are there, what are the enantiomers responsible for chirality, and chirality relation with biology, as many biological molecules, proteins, DNA, RNA, carbohydrates, they contain chirality because of the amino acids. So here we have to introduce the amino acid, and which we have already done. This is a basic structure which on the left side given over here, and following the Kohn rule, going from carboxylic acid to the R groups and to the amine group. If it follows a right clock hand rotation, then it is a D isomer, D amino acid, and if it goes left side, that is anti-clockwise, L amino acid. Mostly in nature we found L amino acid, and here we have certain types of it. seven classifications, starting from the aliphatic, where we have glycine, alanine, valine, leucine, and isoleucine. These are all aliphatics because the sorry, R groups are aliphatic and their journal codes are being given. Similarly, for aromatic, we have phenylalanine, tryptophan, which is given as TRP, and W, and tyrosine, which is given as Y. Followed by we have polar amino acids because it is having OH or NH2 group, serine, threonine, asparagine, and glutamine. So STNQ. Followed by we have acidic amino acid because acidic group is there. So in addition to the amino acid, we have this acid additional COH and glutamic acid. So if their pK value ranges as C3 to 4.5, they retains it their carboxylic acid property. Once it increase, they goes to carboxylate nature. Followed by basic, where we are expected to have the NH2 groups more, so lysine, arginine, and histidine, and sulfur or selenium containing cysteine, methionine, and selenocysteine. And the last type that we have read today is proline, which is a secondary amine, and rest other 19 amino acids are primary in nature. So we'll quickly take certain examples which are very pretty straightforward. Which of the following belongs to aromatic amino acid? So we will take first the alanine. So you should be knowing the structure of your all groups. So alanine is nothing but your R equals to CH3. So if I have C, CH3, H, R, and COH. So 1, 2, 3. So this is L, alanine. So this is not aromatic because the system is aliphatic. Talking about the F, F we know that F stands for phenylalanine, which is having R group equals to CH2 and phenyl group. So this is an aromatic group. Followed by we have W. So we have W, and W is nothing but your tryptophan, and tryptophan is having CH2. So this is again an aromatic. And the last one was L, which is your leucine, and leucine is nothing but the CH2, CH3. So this is again an aliphatic group. Therefore, only the correct answers are B and C. So option B and C are correct. Which one is D amino acid? So the question that we are showing over here is, if you have LCOH in plain, and if you have So here we need to see. So starting, this has to be at the back. This is at back. And if we are giving this as 1 and going to this as 2, then 3. This is following an CO to R to N, the anti-clock. Therefore, it is an L isomer. Whereas here, if you will give it as 1, this is at 2, this is 3, it is going like 1 to 2 to 3, it is clock, therefore D. So this is also done. Similarly, in different examples, you will get different possibility. So which of the following amino acid is having a secondary amine? We have already seen it in detail. So you know that what is lysine. So lysine symbol is K, and this is lysine, which is CH2, 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 and NH2 group R. So this is an primary amine. This is not a secondary amine. Then we have ASN, which is N code, and it is asparagine. It's a polar amino acid having CH2, C double bond O, NH2. Again, this is a primary amine. Then glutamic acid. Again, this is CH2, CH2, COH. Just a second. Not this case we have to consider. Sorry for this. So in this particular case, we have lysine, we know. So if we have H, C, NH2, COH, this is a primary amine, and we have whatever the R group is there, and R is equals to CH2, 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 4 times CH2 and NH2. So this is the lysine. In case of asparagine, R is your CH2, CONH2, and in this case, this is your R. But in all the case, this is primary amine. Whereas in case of proline, it is having a structure like C is having H and COH, and this is having NH and bond. This is your secondary amine. So it is only possible in proline. So this is the right option. The fourth question we have already answered. What happens to glutamic acid if pKa goes to 6? Then at pKa greater than or equals to 6, it stays as a carboxylate form. The last question that we have is, which one is not chiral? So in this phenylalanine case, you already know that it is this is H, this is NH2, COH. For phenylalanine case, it is CH2 and phenyl group. So this is chiral. All atoms are different. Then in case of valine, we have H, C, NH2, COH, CH, CH3, and CH3. So this is also chiral because all groups are different. Then in tryptophan also, your R group is CH2 and this one. So this also give you chirality. Whereas in case of this glycine, it is having H, and in place of your R, it is again having H and COH. So when the two groups are similar, if the two groups are similar, therefore it reduces the chirality. So it is not chiral. So option C is correct. I hope this is clear. Like this way only you will be having your assignment problem. Please try to watch the videos, all the videos, and watch this lecture also, so that you can practice a lot. If there is any other doubt, then you can come back at any point, ask me in the next live session as well. Do practice a lot, try to get more details on the group theory, symmetry elements, and point group. If there is any question, please feel free to unmute yourself and post over here or ask it. Thank you for joining.